Hey guys, this is Professor Janacek. I want to talk about polar coordinates. First thing, let's review a little bit about the rectangular or Cartesian coordinate system. Remember that this has an x-axis, which is the horizontal axis, and the vertical axis is the y-axis. And there in the center, we call that the origin. Now, for the polar, also known as the circular coordinate system, the polar axis is really like the positive x-axis. Notice it only goes in one direction. And then the origin, we now refer to it as the pole. So in the rectangular coordinate system, if we had a point out here, let's call that x, y, those values x and y would tell us where we're moving along our axis. So along the x-axis, that would be our x value, and along the y-axis, that of course would be our y value. And you can see that if we were to draw out where those x values and y values intersect, that gives us a rectangle, hence the rectangular coordinate system. On the polar or circular coordinate system, if I have a point, an ordered pair, in this case the ordered pair is r comma theta. So the first value is an r value, the second value is a theta value or an angle value. The first value r is sort of like the radius of the circle, and theta again is an angle. So we'll use those because r will tell me how far out I'm going, sort of like the radius of a circle, and theta will tell us what angle we're making from the polar axis. Now, again, we could extend this just like the rectangular coordinate system could be extended to make rectangles. The polar coordinate system or circular coordinate system could actually be extended to make something that looks like circles. We don't usually draw out those circles, but you could definitely see them, just like we don't usually draw out the rectangles in the Cartesian coordinate system. Now, there is a way to connect these. Turns out that x is equal to r cosine theta from the polar coordinates, and y is equal to r sine theta. And we can also go the other direction. In the polar coordinate system, r squared is equal to x squared plus y squared. Yes, that comes from the equation of a circle. Or you can write it as r is equal to the square root of x squared plus y squared. Remember, we'll usually consider that r value to be a positive. If it's negative, there are other things you can do with that. The angle theta is defined as the inverse tangent of y over x. Remember that x over y would give us the tangent value. So inverse tangent of y over x is equal to theta. Now this turns out is only true in quadrants 1 or 4 because that's where the inverse tangent is defined. If you're dealing with quadrants 2 or 3, then you have to add pi to it, add 1 period in the tangent world. So add pi to that when you're dealing with quadrants 2 or 3. Let's work a little with these. Let's change an equation from polar to rectangular coordinates. Let's take a look at r is equal to cotangent theta, cosecant theta. Well, first thing, I'm not really comfortable working with cotangents and cosecants, so let's turn them into the trig functions that we really like. Let's write cotangent as cosine theta over sine theta, and cosecant, the reciprocal of sine, can be written as 1 over the sine of theta. Of course, we can combine these. That's the cosine of theta over sine squared theta. Not really crazy about working with a fraction here, so let's go ahead and clear that fraction. Multiply by sine squared theta, we get r sine squared theta is equal to cosine theta. Now I'm trying to match these with my equations, so I see that cosine theta Cosine theta is almost like that x value. All I need in there is an r. So let's go ahead and do that. Let's multiply each side by an r. So that gives us r squared times sine squared theta is equal to r cosine theta. Let me do one more thing and I think we'll have it. This r squared sine squared theta is really some r times sine theta quantity squared. And I think we've got it. I see that r cosine theta is x and r sine theta, that's y. Ah, awesome. So there we go. This is y squared is equal to x. And ta-da, there we go. Everything's in terms of x's and y's, and that's exactly what we wanted. Now let's see if we can go the other way. Let's see if we can change an equation from rectangular format to polar coordinates. So let's take x minus 1 quantity squared plus y squared is equal to 1, all in terms of x's and y's. Let's see if we can write this in terms of r's and thetas. Well, first off, let's go ahead and multiply out this x minus 1 quantity squared. I know that x minus 1 squared is x minus 1 times x minus 1. Multiply that out, and we end up with x squared minus 2x plus 1 is equal to y squared. I'm sorry, back up, plus y squared is equal to 1. There we go, much better. I see that we can subtract 1 from each side and get rid of those 1's. That gives us x squared minus 2x plus y squared is equal to 1. Now let's move that 2x over. X squared plus y squared is equal to 2x. And I think I am ready to change this to polar coordinates now. I see that x squared plus y squared, that's going to be r squared, and I know that x is r cosine theta. Do those substitutions, and we're done. So we get r squared is equal to 2, that stays there, times r cosine theta. No x's and y's now, only r's and thetas. And there you have it. Enjoy!